What's up, guys? Welcome to today's show. So, last time we managed to achieve quite a lot. We are now able to control the entire screen. We can set a foreground color, a background color, we can move the cursor wherever we want, and we can type in text on the screen wherever we want. So today I think we're going to focus on reading input instead from the user. Because usually when you read from the keyboard, you can just do like this. You can't, okay, in this case I could, but often you cannot even remove characters, and you can definitely not use your arrow keys to move around and stuff like that. But we need to have support for that. So I want to create a getchar function, which reads in, or maybe, yeah, I think getchar is appropriate. It reads in a character from the keyboard, but it can also be like a keypress of the arrow keys or whichever key. So it will either return a character, an ascii character, or it will return a specific object with different special characters. So that is my general plan. We have already done the hardest part of the work, because I started this whole project by, let's see, where did we, let me see if I can find that function. This, in the init library, we call a function init library. Yes, we do this term enable. So that is the thing, because usually when you read characters from the screen in C, then you will just get that kind of stuff that I showed you here. You can only get the characters after the user has typed them all in and pressed enter, not before. But we changed that, didn't we? We made it so that we can read character by character. And that was this stuff that we set up. So now we get to use that thing. Yes. So let's see here. We're gonna have let's code a private function first, I think, which we then can call from our API function, because we might want to use it in other occasions. So let's say we have a private void, or not void actually. We do want to return something, but I don't know what to call this data type yet. So let's just wait with that. So getchar, and what do we need? We need to have a window, right? And that's basically it. Yes, if we know the window, then we can read a character from the keyboard. Maybe we could have some kind of flags parameter if we want to like enable echo or something like that. No, I don't think so. Not in this private function anyway. Maybe we can add something like that for the other one. So this is it. Okay, but what about this data type? We want to return different kinds of objects depending on if it's an ASCII character or not, right? So, where do we have our data types here? So let's start by defining a structure. Don't we have any structures? Oh, down there. Okay, dokes. So we're gonna have a struct s. What should we call this thing? Character, but it's too similar to the other thing. Key, that's a good one. All right, so a key is going to be different things. So we want to have a union inside of here. And let's make it an anonymous union. So a union is like a structure, but whatever we put here, if we have int x, int or char y, for instance, then this union will not have the data capacity for both of these, only one of these at a time, so to speak. So it's either an integer, which is called x, or it's a character, which is called y. And usually you put in a name here, or something here as well. But if you don't, you should be able to refer to this just by x and y, which makes it a little bit better. I have never tried this, by the way, but I'm pretty sure I read it somewhere. Alright, so what are we going to have inside of here? Let's say we have something like a key code, or we have a regular int8 character, which is our, what do we call this, char. Something like this, and I think we need to close this union. We need to close this, and let's type def struct s. Maybe we shouldn't have int8 here, by the way. It might make sense to have, we can put it here instead. We need to have some tags so we can differentiate between those two. So let's say we have, what should we call this? Key type. And this can be the type. Or did we, I think we called something else type. Key type. This is good. Oh, tag is even better. So we type the struct s key to just key, like so. And now we just need to define this key code and this key type. And we'll be right back. Alright guys, welcome back. So, where were we now? We were creating this key data structure. So, I want to change this a little bit. Let's say this is an int8 instead, and we're not gonna have a whole lot of tags. Currently, there's only 2, but there might be a couple of others. So let's say we allocate 2 bits for this. That gives us room for 4. different combinations. Let's see, do we have packed? Yes, we do. So let's make this packed so we don't have a lot of space in between those variables. So we need to define this as packed and this. Right. So I was considering using an enum here, but that's not really necessary. We can make a combination. We can do an anonymous enum, and then we use just this regular int 8 here. And what do I mean by that? Let's go up here and we just do enum without giving it a name or anything, and without defining any variables of this type. And then we can simply do stuff like, let's say, key undefined. And then we have key, maybe I should have a big U here. And then we will have the character. And something for special, let's say. And we want this to be packed as well. All right. So now that's done, and we have this already. We need to define the key code. So let's see here. We could use the same trick here, I guess, because here we will only have like a list of different keys, like arrow, left arrow and stuff like that. But I think I want to give this a proper name though. So let's say we have an enum e. Yeah. What did I call it? Key code. Maybe that's a bad name. So this is the character. Now what should this be? Let's call it special key, like this. We'll call this special. I'm always having trouble figure out good names for stuff. So this will be an ES key. And let's use the same syntax here. We can't do undefined again though. So let's say we have a key none, and then we have left arrow, up arrow, right arrow, and down arrow. Let's add those K's as well. Or maybe we remove all instead. Like this. And we will have more than these, but that will suffice for now. And then we can type def enum ES key. key to be ascii. Alright, so now we can start with the actual function reading one of these from the keyboard. So here we are going to here we are going to return a key, like so, and maybe it should be this. Right. I think this is the right way to do it. Let's see if it will work. But let's create this function first. So basically we need to take care of two different scenarios. Either we'll start by executing a read call, and either we will get one character back and then we're done, or we will get the escape sequence, and in that case we need to read in a couple of more, like 2 or 3 more characters, and those we will interpret into different stuff, like the arrow keys. So, and the escape sequence, I believe, is the same as in the ascii, which means it's this. So 1B hex. So this is what we need to do. So let's say we have the function first and foremost. It is a private function. It will return a pointer to a key, and it is called getchar. Takes a window, win as a parameter, and that's it. Okay. So we need to have some kind of variable for storing the byte that we are reading. So int 8 bytes, let's say. And byte is going to be equal to readchar, which is a function that we need to define. Actually, do we really need the window here? Because reading from the keyboard, well, if we need to echo the thing, maybe. But that's probably the API call that will handle that. So I think we will use no parameters here, actually. At least for now. So let's remove this. And I can also define the other function, which is a private int 8 readchar. And this is not going to take any parameter either then. Okay, so we read in 1 byte. And if this byte is 0. Let's say 0 is an error. So we're not reading in any null bytes. In that case, we want to return an error, so that would be a key 0. And otherwise, we will switch on that byte. We're gonna have a case for the escape sequence. X1B, if I remember correctly. Yes. And then we're gonna have a case for everything else. Like so. And if we read in a regular character, let's, by the way, create this structure first. So we will have a key, and let's call this just P for pointer. So if we go past this stage, so before the switch, we need to know the size of this thing. So let's have it in 16n, where n is equal to size of struct s key. And in case we have one of these, let's see. Never mind. So we're reading this, we calculate the size, then we allocate. And I don't remember, did we use the alloc in this project or not? I think we did, right? No, that was another project. Okay, let's use the regular malloc. I have so many different projects, it's difficult to remember sometimes. So this will be cast to a key, malloc the integer of n. And if this were to fail somehow, let's return an error. Otherwise, we can clean this out. So we zero out. Zero out the P with n bytes. Okay, so now we have something to work with. And in case of a regular character, that means that we want to create a structure which has this and this. So we want to set the P tag equal to, and what did we call this? Char, I think. Yeah. here, just to be very explicit, we can let it start as unsigned or undefined. Which one did it be? Did we choose? Undefined. Okay. And we know the character at this point, so let's set the character equal to the int 8 of our, or maybe it's an int 8 already. Yes, it is. So it will just be equal to the byte. And that's all there is to it. And after this switch, we want to return P. Simple enough. But then we have this slightly more complicated case. And I'm not sure, we need to experiment a little bit and see what we get in this case. So maybe we can temporarily add an endless loop here. And this is very temporary, as you might understand. So we can do something like this. We set P equal to read char, and as long as this is not 0, so practically an endless loop, we will just print what we get. Let's print it as a hex character, so .02, 0x% .0 hhx. And here we will have the char of P. Because then we can press down a couple of different keys and see how many bytes we get and what we get. Otherwise, we will return the thing. And just for the sake of it, no, never mind. This is good enough. So we need to create this read thing, and that shouldn't be too complicated. It's going to be a private function. It's going to return a single int 8. It's going to be called read char with no parameters. We need to have some kind of temporary buffer. So let's say we have a, let's do this, int 8 buff 4. And we will zero out this buffer. And then we will do a read call, and we have standard in out error. So in 0, we want to provide the char version of our buff, and we want to read at most 3 characters. And then 0. Oh, we can't really do that. Let's do signed int n instead. Then we can do this. And in this case, we will just return the first thing. By the way, we just want to read 1 byte. Right. So let's do something like this instead. And then we will simply return the first character of buff as an int date. And otherwise, we will return 0. And that's it. Okay then. Let's test this thing. So how do we do that in a good enough kind of way? I think the easiest would be to just treat this as a regular screen, I suppose. If that's still an option. Let's see what happens if we comment out this stuff right here. And we jump up to the top left corner. And what do we want to do now? Let's say we have some return value, which is a key. And let's just do while key is equal to, what did we call the function? Getchar, right? Right. So this will loop as long as it's not an error condition. And since it can only return characters at the moment, because the other ones, they just print to the screen, which means we can do something like let's do this. And we need to, let's see, we need to cast it to a char, and what we want to return is k char. That's the one. Maybe just for the sake of it, we can clean up afterwards. So if we have a k, we want to free that k. Something like this should be enough to test out our functions. Conflicting types. Getchar, private key, getchar. Private key, getchar. Private key getchar. Isn't that the same? we have private int8 read char. We have private key getchar. Private key getchar. Private int8 read. Is there something else which is called getchar perhaps? Okay. The standard library contains a getchar. That's a little bit annoying, since there's no good way to just filter out one of these. So we'd better just change the name of this thing. Get character, or let's do getch, since we use the ch abbreviation in other places. So this would be getch instead. Let's see if that works better. Assignment to key star from int8. That should not be read char, it should be get char, right? No. Read char. P. Right, this should be P. This should be byte is equal to read char. And we should print byte as well. So just parentheses, I don't care about that. This is a temporary thing. Assignment to key star makes pointer blah blah blah, while k equal to getchar. Oh, getchar is a standard C function. I need to change that as well. So this should be just getch. Sounds like a German word or something. Getch. But now I think it will compile. Yes, and let's see what happens. So now I'm gonna press a couple of characters first. So it looks pretty good. So let's try the arrow keys. 5B41, 5B43, this is the right key. 5B42, 5B44. And what about things like control? Doesn't react to that. Tab. Okay, backspace. All right. What about insert? Okay, so some of the special characters does not trigger. And I wonder if that's really a problem. I don't think we need it right now, at least. Okay, so let's see. Left, up, right, down. That's the order that we used it in our code. But everything works this far. That's great. So now we just need to interpret those arrow keys, and probably a couple of others, but let's start there. So So we can replace this thing here. Let's start with a comment with the information we gathered. So it always starts with, let's see, 5b44 1b, 5b41 1b, 5b43 1b. Is that the right order? This does not end in that. 5b44 1b. We have 1, 2, 3 1b's. We have 1, 2, 3, 4, 5b's. And 1b, is that the yes, that's the escape sequence. Ah, okay. Now I see. We have this endless loop here, right? So the first 1b doesn't show here. It starts with 1b. That makes sense. So the 1b, we have a handle here. So if we get a 5b next, then we want to read one more character, and that's the interesting one. So we can just take this step by step. We will do byte equals to, let's see, is this aligned right? Yeah, that should be down here. So we'll do a read char. And if that byte is equal to 5b, in that case, we want to read some more, or one more. However, if it's not equal to that, then it's some undefined key. So that's what will return. So we'll take the K and it's let's see, my cat is fighting me for the keyboard. And he just accidentally put his foot on the enter key. So let's see, I think we call this just special. So in the other case, we want to set this to none, right? And we don't need this. So let's see, we will return that, and then down here we can return P. By the way, this should be P. And here, I guess a switch is on. Can we have a switch instead of a switch? I'm not really sure, but it should be possible, I think. So we will have a couple of cases with a 0x for something. And we want to set our special to something and break out of here. And then we want to have a default case where we do as before, we set special to none. And I guess that's the whole thing. So then we just need a couple of these. 1, 2, 3, 4. So let's see. First we have the left key, and that's 44. So this is the left arrow. And then we can delete it. Then we have, let's see. So 44 was left arrow. This and this. And then we have one of these and then this. So 41 is the next. I will clean off these other ones. So 41 is the next, and that was the up arrow. Then we have 43, which is the right arrow. And finally 42, which was the down arrow. Down arrow, like this. Okay, now it's starting to look pretty nice, right? We do, however, need to make sure that these line up. So this is the switch. Return P. So here we have the switch, and we have an if at this level. Okay, then we have an else, and then the end of the switch. I don't think we should have this one, right? We should have a break here instead. I think this is right. Alright, so that's it. Now we just need to write a better version inside of main, because we have what we need right here, if it works, but I think it will. So after the break, we will continue with that. See you in a bit. Alright, welcome back you guys. So before the break, we managed to achieve this. We have some problems with, well, it starts to print in the middle of the screen, and at line 1 in this case, even though if we go into the code, 1 second. We'll just arrange my windows a little bit. As you might have noticed, I changed to my Windows machine. Alright, so let's see here. If we go to the init function, we create a window which is 15 by 20 characters. And we are trying to print on, I guess this is the line 0, position 2. And as you can see, we are printing from the start of the middle of the screen, not almost at the leftmost top corner. So something is wrong with our calculations or with our printing routine. So I think the best way in this case is before we, let's see, we do the print, but before we do the update, let's do something like this. Let's put this up here, and then we use our show function. So we want to show our window, I think it is. Or let's do the frame buffer. That's the interesting part. So show frame buffer. I'm not sure if we created a show macro, did we? No, not yet. All right, so let's do it like this. Let's see, what's this? Num. Let's see what the second argument is. I don't remember. In 16 num. Okay, so I guess it's how many frames we want to print. So how did we do it here? Num equal to, yeah, we take the whole screen. Alright, so let's see what happens if we do it like this. Let's recompile. Too few arguments. That's right. There we go. Okay, so here is it looks really weird. This should be our frame buffer. I guess the colors are correct, 7 and 0. But our hello world starts very late. There are 3 lines here. So it's 1, 2, 3, 4, 5, 6, 7, 8 in each. So 16, 17, 18, 19. At position 20, even though we say 0 and 2, which should probably be here somewhere or here. And all of our bitmap are 1. That could actually make sense because we do this frame set here where we color the whole screen. So maybe we should do an update first, then we do the jump and the print, and then we do this. It should be C update. I do, however, want an alias or macro for that as well. So let's say we have a define, and let's just call this, let's see. Let's say we have a function called update, which takes an X, which is a window, And the only thing we're going to do is, no, we're not going to take the window, that's the whole point. What we do want to do instead is we want to run cupdate and provide our global state and its root window. That's what we want to do. Because then we can, instead of just saying cupdate and that stuff, we can just do update. Because most of the time we are going to use our primary window. Alright, so let's try this again. Global state. Global state. My L key is a little bit troublish. Okay, now it makes sense. So now we're only seeing zeros or the stuff that has not yet been updated and printed to the screen. We still have the same problem that it's far too much ahead. And same here, a lot of zeros before the first one. So this tells me that the problem is not the update function, which actually prints the stuff to the screen. The problem must be our move. So let's see, C move. C jump, I mean. Alright, so what do we do here? We take a window, we take an X position, and we take a Y position. And the max X are the columns -1. Makes sense? And the max Y are the rows -1. And if X is more than max X, or if Y is more than max Y, then we return. Otherwise, we set the windows X to X and Y to Y. And when we do the actual put char, what do we do then? No, not this. Here. We do the same calculation. We take the X from the window and the Y from the window. And if X is less than the max, let's see, so we update the window. And if Y is the max, set it back to 0. But we use the current values when we print. So far so good. This must be the problem. SFBXY. SFBXY. So this is our set frame buffer function. Do the same calculation for X and Y. Make sure we don't overflow. We calculate the index to Y times the max X. So let's see. We provide this function. We gave the values 0, 2, which means that x is 0, y is 2. And I don't remember what size the window was, but if we say that x is 25 and y is 15 or something like that, then we take y times the max x. So our max x is 25 and our y is 2. 2 times 25 would be 50 plus our x, which is 0. So this should be the position. And if y is 0, we only use the x. It looks kind of right, doesn't it? What about this SFB linear? So here we take an index instead. And we make sure we don't overflow, calculate the color and the character. And then we take the frame at position index. Let's do something like this. So index is equal to something. So the age here means that we're dealing with 16-bit numbers. So this is going to be short int index. And let's run this. Let's see if we can find this thing. Okay. So where does it start? Okay, so here we run through it when we do the set. So we fill the entire screen. It starts from 0. Makes sense. Goes through all of them. But then when we try to print, we start at a very high index. 284. So I guess this is the HELLO space WORLD. And this might be new line or something. So it starts at 284. What if we were to try to use 0, 0? Let's, by the way, also print something similar here. So if we take this here, 2dd paste, but here we will print x is equal, y is equal. And let's go to our main. Let's try to jump to 0. And let's remove this new line. And let's try this again. So x is 0, y is 0, index is 55. X is 1, y is 0, index is 157. That's a little weird. So in this function everything seems right. But the index calculation fails somehow. Or is it propagated wrong somehow? We can try to see what it says if we try to print it here. Okay, this looks right. X is 0, y is 0, index 0, index 1, index 2. But here it becomes 0, 5, 5. Why is that? So we have 1, 2, 3, 4, 5 arguments that should be linear. 1, 2, 3, 4, 5. And this is an int 16. This is an int 16. How can it change? What am I missing here? You have probably already figured it out. And why does it print a 0 in front of... Oh, wait a second. Maybe it prints index is equal to 0 and then the 5, 5 is something else. Could that be it? But I have a new line there. Let's do it like this. Mm-hmm. Very weird output. Very weird indeed. Okay, index is 0. Index is 1. Okay, so it seems right. Does only look weird when we print it. And how does the frame buffer look? Okay, so now it's at the right place. But I didn't change anything, did I? Now everything looks right. What if we were to try to print the real thing this time? Okay, now it almost worked. What did I change? I thought the only thing I added was the printfs. Did I change anything else? Weird. Why doesn't the H print, by the way? It makes a long jump here. It takes X and then Y. So this should print it 2 steps to the right. Which it kinda does. It's off by 1. Why is it off by 1? Maybe it's 1 indexed when the ANSI prints to the screen. Could that be it? So ANSI move. Let's see what happens if we run this. That looks more like it. So 0, 0 should be the top left corner, which it is. And if we go down 1 line, it almost works. It still doesn't quite calculate it correctly. So how many characters is this? "15." And what did we say when we initialized this thing? We said 15 columns. But that's not what it prints. What if we comment this out? No. It almost works now, but not quite. Because we take the number of columns and we times it with y. Which is 15. So it works with the x-coordinate, but the y-coordinate is not calculated correctly. Let's check out the update function. Go from index 0 . We go from index 0. I think I added this during the troubleshoot. I think this is what we want to have. Maybe that's why. Because we want to be at line 1. Let's double check if it still works this way. Yes, it does. And how many characters is the whole line? Let's copy like this. 20. And if we check the inits, we have 20. Maybe we mix up x and y somewhere. Make with columns, rows. Oh, wait a second. Just for the sake of it, let's try and see what happens if we do this. So where are we now? Okay, we're at 0, 1. 0, 0, I mean. If we do this then. And now it works. But it doesn't really make sense, does it? Because this should be the max x, right? It's like we mix up the columns and the rows somewhere. Let's just do this. Because now it works at least, so let's not change anything else for now. But we remember that this was kind of weird. So where were we? Yeah, we wanted to make our we want to be able to read stuff and want to print what we have. So we want to have a show function. But let's search for all printfs and not here though, but if we have some printf that's not really a debug message, we want to do a C print instead. Okay, we don't have many of those. Alright, so let's create a show function. We can make this private. So private void show. What did we call our new data types? Didn't we create one which was called key? Ah, here it is. So this is what we want to show. So show key and we take a pointer to a key K. And we want to know what type it is. So we want to switch. Let's first check that we have a K. So if we do, we want to switch at the K tag. That's right. So we will have a case for so we have character and special. And default, we don't want to print anything. So if we have a character, we want to print. We want to do a C print. Something like this. And we want to have the character of K. So what did we call this? CH. Maybe we can even print it like this. And if we have a special, then we need to do another switch. And we want to switch on the K special. Yeah, on the K special. So in this case, we will have a up arrow in which we want to print that. So something like something like this, right? 1, 2, 3, 4. So we will have down, and left, and right. Maybe we also want to be able to print none. And we can't forget the breaks. And let's also add a default in which we can print something like other. And I guess this will be our entire function. So how do we test this? So let's start at the top corner. And remove this. And we will have a while loop. So while, and then we'll have a k which we set to getch. And then we'll show key k and free that k. Something like this. Implicit declaration 19. That's right. This is not called printf, it's just cprint. Oh, we need to update as well. Maybe we shouldn't have these annoying little things. But we can have a space instead. So A, B, C, D, E, F, G, H, up, left, down, right. Okay, so the arrow keys don't work. This key special. And these are the S keys. Let's add something in case we get something which is not one of these. So let's say let's just print error or something. So we'll do up, down, left, right. Okay, so we don't get the special. So let's check out our read key. Read char, okay. Or rather getchar. So let's see, if we get this, we read in another character. And if that is 5b, then we read in one more, and then we switch on that. And we set p special to those different kinds. But we never set the tag, do we? Guess we should do it right here. Okay, so A, B, C, D, up, down, right, left. Okay, that's pretty nice. So now we can both print stuff as we wish, and we can also deal with the arrow keys. And if we press something else, I don't know what that could be, this perhaps, no. Delete maybe, yeah, there we get a none. So we can trigger on the delete as well. And page up and page down. We can do a lot of things now. We can probably code something which let us move like a character on the screen or something. So that's pretty nice. Let's see if we can figure something like that out after the break. So see you just in a bit. All right, you guys, welcome back. So now we're able to successfully write to the screen in any way we want to. And we are able to read characters from the keyboard as well. At least regular ASCII characters and the arrow keys. But it's easy enough to add more stuff to that. So let's see if we can't create some program out of this now. Because this is what we have currently. I can type different keys and they are printed on the screen. So there's a couple of stuff I want to do. And I want to start by creating a macro so we can easily grab the current X and Y position, because that's strictly necessary. And I'm going to do it like this. So let's see. We can create one macro. Which takes an argument. So let's call this cget xy. And it's going to take a window as a parameter. And what I'm going to do is I'm just going to return that window. Yeah, I'm just going to return that window. Because the window itself, if we look at the data structure for the window, if we can find it somehow, it contains this X and Y coordinates. So if we just return that window, we can grab those parameters pretty easily. So let's also create a getxy, which does not take an argument. And this will simply return the global state root. And a better way actually would be, instead of returning the root window when we do these simplified functions, is we should have a pointer pointing to the current window. Yeah, let's add that. That's easy enough. So let's see here. So in the state we have a window root. Let's add a window current as well. And when we create the initial window, I think it's inside of the init function. So let's see, we create the global state, and then we create the window. So let's see, let's go to that make window function. Do we have some kind of check if this is the root window? Let's see. If window ID is 0, okay, then it's a root window. So in that case, let's also set the current window to this same one. And whenever we change the current window, we need to update this pointer as well. Because then we can easily use all the different places where we use the global state root, like the print function, we use the current instead. And same with this update function. And our new one. So this should be current. And I'm not sure if we have any references to the root inside of the C file. Let's see. No, we don't. So now we have changed all these places. So let's see. Let's remove some of this code. We should also create a function to set another window as the root window. No, not as the root window, but the current window. But let's do that later. For now, I wanted to see if this works. So let's jump to, let's say, 1, 3, and we'll create an int 16, maybe it's an int 8, x and y. And now we should just be able to do something like x is equal to get xy and then we take the x, and we can do y is equal to get xy, and then we take the y. This should work, right? So let's do a cprint. So x is equal to something, y is equal to something. This is x and this is y. see if this works. Yes. And the code looks kind of cool, right? With these arrows and stuff coming out of this function call, or function-based macro at least. All right, so now I guess we have pretty much what we need for us to be able to create that little thing where we move some cursor or something around the screen. So let's call this our main one. And we don't have to give it any arguments for now. And let's also, maybe we should put that in the bottom. So we'll have a regular main function as well with a full signature. And here we will just return main2 in this case. So let's create main2. Let's also update our signatures. And I will do a space in front of this because this is a temporary thing. Same with the main2. All right, so I want to be able to move a cursor around the screen. Before we begin, let's go to the init function and make this window a little bit bigger. Let me see how big my terminal is. If I echo lines and columns. So let's do something like, I don't know, 130 and 35 perhaps. I don't remember which one is first. Let's go to the make win. So the columns are first. So that's the X. So let's switch these up. This should be 130. This should be 35. And let's just see that it looks right. Oh, I need to change this to main1. Think it bugs out when we create a window which is too big for the screen. So let's go back to the init function. And maybe I mixed those up. Yeah, okay. All right. So let's create our main2. So we're going to need to have a key and well, let's start by doing a, what did I call it? Frame set. No. C frame set. Ah, we need to do the ANSI mode first. Right, so ANSI mode, and then we call C frame set. Let's also create a window. Alright, so we give it the root window, and then we need a character. Let's just do space. So this function sets this to every position on the entire screen. Alright, so foreground doesn't really matter here, but let's try black. And the background, I need to check what we got. Green, perhaps? Ah, we need to update. I always forget the update. Do we need some parameter to the update? No. C update global state current. Oh, I forgot to set the window. So let's set win equal to global state current. Now it works, but the colors are pretty hideous. Let's switch. Let's do green color, but black background. And let's see, jump the window to somewhere in the middle. So let's say 65. And the Y position, we have around 30, so let's say 17. And then we can do a C print. And by the way, we can't do this because we need to provide both the format string and one argument. And that's just a limitation of the macro I wrote. I want to try something out. I wonder if it's possible to do, let's see, can we print a character where we give it a string and we take the address of that string and we dereference this as a char. I wonder if that is possible, because that would be kind of cool. Then we can fix that macro thing. It compiled, right? 52. An empty string's first character should be a 0 byte, no? Huh, it worked. How cool is that? So we take this empty string, we take its address, and we dereference it. So basically this means, it probably means that we can do something like this. So let's see here. So we have a format string and we have args. And here we use that arg. But if we do this trick, so I think if we do double hash symbol and then args, it should be turned into a string. And since it's empty, I guess it should be an empty string. Same as our example. So if we were to take the address of this, and then we dereference it like this. So if this is an empty string, it should return a 0. So if this whole thing is negative, then we can just give a 0 perhaps. Otherwise we provide the args. This should work, right? Maybe it should work. So now I should be able to do just this. If I get all the parentheses correct. Expected expression before the token. Maybe it's not double, maybe it's just 1. expected blah 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 before numeric constant. Oh, this is what I meant. Well, it compiled, or didn't it? I guess this will just be a blank space in this case. So it doesn't work. Bummer. It was a pretty cool solution, I think. Well, well. Minor problem, no biggie. We can still do this. Alright, it works. It always defaults to the same colors though, when we use that function. But that's just the way it is, I guess. cprintf args, cprint prime, buff. Yeah. Well, let's use those colors. So our foreground is black and our background is white. We can still make our little cursor thingy green because we'll be using the put char instead of the print function. So let's did it do the jump though? Seems to be printing on the top left. Now I think I know what's wrong. When we create the window with make win, we take the cols and the rows, and the cols are the x. Cols and rows. I think we have mixed up the cols and rows somewhere, but I don't want to put in a lot of effort in troubleshooting that right now. We need to fix it for sure, but maybe not this second. Let's do this instead. So let's do something like 15, 10, 15. So x, y. Okay, wrong order. Why did the D end up down there? That's a little bit weird. We have some trouble with that stuff, but let's fix that later on. So 15, 15, let's do 5, 7. Yeah. All right. Let's not focus on this. So let's remove this thing, and we want to keep track of our cursors, x and y positions. So let's create variables for that. And let's do something like let's create a boolean which we call continuation. So if we should continue looping or not. Yeah, okay, let's do that. So continuation is equal to true. So let's set our x to get xy, x, and y is get xy, y. So let's do a while loop as long as this continuation is true. And the first thing we're going to do is print our character. Or before that, we want to clear the screen. Now we print our character. So we can do the c put char, give it the window, and the character, let's say an O. We need to make it an int 8. Foreground green, background white. And then we update. So now we have printed our character. Now we want to read from the keyboard. So we'll set our k equal to getch. And if we have a k, maybe we can do this. If we have a k and the k tag, let's put this in parentheses, is equal to a char, and if the k char is equal to q. So we press Q to quit the game. That's the idea. So in this case, the only thing we're going to do is set continuation to false and break. And let's remove this. And let's just do, if we don't have a k, we can continue. So else if. So if we get down here, we know that we have a special character. It can be, let's do this differently. So if we have a k, and our k tag is equal to char, in that case we can do another if statement. If the k is equal to q, this needs to be an int 8. Then we do this. All right, so now if we get down here, we know that the tag must be a special character. So we can switch on the K special. And we'll have a case for the different arrow keys. Okay, so if we press the up arrow, then we want to decrease the Y, so we move upwards. But if Y is already, let's see, if Y is 0, then we want to do nothing. Otherwise, we want to minus it by 1. Yeah, that's about it. And if we press the down arrow, let's see, how many lines did we create? 15, 15. Okay, that makes it a little bit simpler. So 15 lines means from 0 to 14. So if Y is more than 13, let's say, then we'll just continue. Otherwise, we will plus our Y. And then we have our left. And if our X is 0, we continue. Otherwise, we will decrease X. And then we have right. So if X is more than 13, we continue. Otherwise, we will plus X. And then we want to move C jump of the window at the X and the Y. And that's probably just about it. Okay, it kind of works, but it's very unreliable. Why is that? We can move up and down pretty easily. But it does not work very well. Because we clear the screen and we print this thing and we update. Does it quit when we press Q? Yeah, that works. This is pretty weird. By the way, we need to clear that thing when we're done. So our X position starts at 5. So let's say we press right, then it should go to 6. Are we able to print at that location the initial thing? What? Something must have gone wrong when I uploaded. Okay, it printed correctly. But when I press right, it does not work. And if we go one additional position, it still works. So why can't we just do that? Right arrow, if x is more than 13, which is it's not, x plus plus. And then we jump to that position. Let's check what x and y is at this point. Seven and seven. What am I missing here? And why does it work for the y but not the x? Now it works. Okay, it gets a little bit too far. Let's do 12 here and 12 here. It gets a little bit too far still. Okay, that's better. So now we can actually move this thing around the screen. But I wonder why did it change so drastically when I move this C jump from the beginning to the end? Why does that matter? I'm not sure. By the way, let's do this a little bit better. We are leaking memory when we do it like this. So let's free the K. Like this. same here. And here as well. And hopefully this still works. Yeah. So we can quite easily create some kind of game using this library because we can control a cursor on the screen. We can also create things like text editors and all that kind of stuff. We however, need to fix some of these small bugs when calculating the screen. But we have solved today's problem by successfully parsing keystrokes. So I hope you have liked this episode and that you have learned a lot of stuff. Don't forget to like and subscribe. And thank you for watching. Thanks for today.